Okay, previously on Building Site we were doing a GraphQL implementation from using ANTLR. So we'll carry on with that today. I wanted to finish off and show how we could also parse a document, and then we might get a bit further on and then work out a query, how to use that document as a query, and finally get some results back. And we'll see how far we get with that. So over to the code, just to recap what we were doing. We had a whole load of multi-methods. We had one multi-method which was going to process the output that we get from ANTLR. So just as a recap, this is the output that we get from ANTLR, which is a parser, and when we use it, okay, we get this, and this is what we have to process. So closure to the rescue, multi-methods kind of cut through all of this, where we kind of recursively take each section. We look at the first thing, which is why we have a multi-method that uses first. If you don't know about multi-methods, there's a lot of documentation online. Closure Docs is a good one, and you can find. Yeah, let's go and carry on process it. So I'm going to race ahead. We've got a schema which is called schema 3, and last time I was actually just not using namespace keywords. So now I've added a namespace, and this is partly because I have the beginning skeleton of an evaluator, and this one is using these namespaces. And namespace keywords are kind of handy when you have data from different sources and you can just merge them, so without losing any information. And it also tells you where each entry kind of came from, which can be useful too, especially when you're debugging. So here we are. We have one last thing that can't be handled, which is a schema definition, which we might as well finish that off. And then I want to write a document that you might want to use this schema to query. Now, one of the questions that I anticipate might come up is, why aren't I using Licinia? Which Licinia is a really good GraphQL library for closure. It was written by Howard Lewis Shipp and his team at Walmart Labs, and it's quite old now, and particularly what I'm interested in is creating a code-free, serverless, if you like, environment for coding GraphQL. So what I would like to be able to do is define a schema like we have here in text, have someone upload that to site, to also to use directives to attach it to Crux in some fashion, and then finally to post that schema up to a URL, or put it at the URL, and that URL they can then post other GraphQL queries to, and hopefully get results. And that would mean that there would be no code to write and no resolvers to write, and the whole thing can be codeless, which is the aim. And that kind of goes hand in hand with our vision at Juxt, especially of making the type system, I guess, the schema, as fluid as the data in a database. And too often, well, my observation observations through a number of different experiences as a programmer, developer, is that we very quickly hard code or codify the schemas and type systems inside of our languages, inside our databases, and they kind of weld them to the data very early on. So in your code, object orientation is full of data objects, which are then part of the code base, and they shouldn't be. In my view of the industry, what we should be creating in code is machines that can take in input data. So a machine is something that can kind of read a set of instructions, and it doesn't have to be constantly updated. You don't have to continually tinker with a machine that you can program. So for example, a C compiler reads in a program and compiles it, and you don't need to continually update the C compiler. When you update the C language, you have to update the C compiler, but you can write lots and lots of different C programs without updating the compiler every time you make a change to your program. So I think that's the that's the gist of it anyway. So we don't want the type system of GraphQL to be kind of written once and for all and encoded into some server or service somewhere. That would require us to take down that service where we ever want to update the schema. So what we want is that schema to be almost like a living document. We can edit it and then we can upload it, and we don't have to bring the service down. So we should be able to deploy it in milliseconds just by overwriting the previous schema. When we overwrite schema, though, we do want to keep track of what we've overwritten and have a history of schemas going back in time, and that's why we need a temporal database to do that. And so you can use, there's a lot of databases that have support for this, and one is Crux that we're building in Juxt. So hopefully that's sort of clear as to the motivation. I'm going to crack on with writing a little document. So let's say we had the schema on the left hand side. What kind of queries would we do? So let's create a little query. I'll call this query 3, and this would be our root query would be say query, and we'll say because this is at the root, we can say we want user where the ID is 4 perhaps, and that's going to return us a person. So with our person we can choose which fields of that person we're going to have. So I'll just say give us the name. Okay. So what we'd like to do is first parse that query. So let's do that. Oops. We can slurp the resource. Oh, what did I do there? No, didn't want to do that. I wanted to do this. And there, we put the two up together. You can see that, well, when we were querying our query, we got a not handled. So we're not handling a thing called an executable definition. So then we go back to the spec, and we will look for executable definition. Oh, that's useful. And we're told it's an operation definition or a fragment definition. So up here, we can say, well, definition is an executable. Sorry. Yeah. So we take the key that wasn't handled. We write. This is in no particular order. That's going to take a list, and so we can do structure. We don't need the first, but we do want the inner one, which in our case will be operation definition or fragment definition. We don't really care at this stage what it is, we just process it. And so now when we add that method to the system and recreate, to find a faster way of doing this, we're going to get operation definition is the thing that's not handled. Let's put my methods lower down. Brilliant. Okay, operation definition. Click on that one, and that has some terms. What are we going to do with those terms? We're only interested in the sequential ones, which are essentially our non-terminals, which are all of these, but we might as well filter. If we have anything that is a token like that, then ANTLR will pass that back to us as a string and not a sequential, which is a list. Okay. Then we are going to process each of those, and we are going to merge the results, and I think that's all we need to do. We'll see what happens now. Selection set. Okay, we've got to create a selection set. Is this thing or this thing? It's the bit in between the braces, which is what a selection set is. So try and do a bit less typing. We have these would be our selections, which would be a list of selections. It's the first time we've had a list, so I think I'm going to just see what they are. Bang. So in our case, they're going to be singletons. That's what a selection set looks like. Okay, because we're not processing each one, so it looks like a selection. So we've got to process each of those selections, and we don't need the braces, so we will just get the sequential ones, and we will use the thread macro, and now we're not handling selection. You really kind of want to have a fast forward fashion here, because this is really not particularly interesting. The vowels here will be the fields. Is that right? I think so. We can tell. Selection is well, not necessarily fields. It could be a field or a fragment set or something else. So a selection here will be what we've been calling an inner. So an inner is a field or a fragment spread. So we want to process that. And we should say, we don't know what a field is. Take a field. Let's click on that one. Well, have a bunch of terms there. Again, we will take them, filter them, process them. I can't help thinking that we need... Okay, we'll carry on with this, but I'll put a quick note. Wouldn't it be easier if we handled strings? I think it would. and we can fix that. We can easily make a more sophisticated multi-method to do that, but we'll just finish this one off. So what do we want to do here? Well, we want to process each of them. They're going to return maps. We're going to merge those maps together, and that would be in a field. And I suppose we could say this is really like the selection type, which we could say is field. I don't know if that would ever be useful. We'll see. And we don't need that. Okay. Selection set not handled, field at. I don't know what I did wrong. Oh, not handled, operation type. Ah. And then not handled, field. Hang on, a selection. It's just going to have one parameter there. Okay, that's better. So we have a selection set. I guess it would be quite nice to return a vector just for reasons, and we've got to handle the operation type. Let's go and find operation type. Operation type. Let's go right to the top. We know that we have a document. Here we are, and an operation definition, and that has an operation type. Ah, that's what we're struggling with. So an operation type. And that would contain some terms. Yep. And no, it would return 1, and we would just return that value. I mean, we could do this, couldn't we? If we were so inclined. Subscription. These possibly you want to return a map. here. Okay, operation type is query. That has a selection set of this stuff, and let's just perhaps let's put a little commit in there saying that we're begin to process the document, just so that we've got a checkpoint to move back to. I'm on a branch anyway, and we may rebase, but I just wanted to simplify this. So this is going to be a function that takes a list, call it a collection, and it is going to return in the case that the first of the collection is keyword, which we can destructure. Then return it. Otherwise, if it's a string, we want to return the string. We'll call that constant. Okay. And the idea here is that you wouldn't need to filter. Let's find something that does actually have a constant, which was a selection set, because a selection set has braces. So we have to do that. And then it's doing a first of the, and we're getting a closing brace in that case. Because we haven't. Did we re-evaluate the multi-method? Do we want to remove this unknown space perhaps? Do I know what I'm doing? Not really. I guess it's hitting this default thing. I need to put constant in there. Okay. So this means that we're just dealing with a token, which will just return as a normal token, and then, great. Do we want to return it as a token? I guess we don't want to return it as a token at all. So filtering is quite a good idea. Unless we return, we could return nil, and then we would get nils in here, and then we could do things like, we could do a keep. So we could replace map process with keep process. And then we would get selection set. I knew this was a bad idea. Because that was my fee. Vector. B. Let's see what we've got there. Has it helped? Well, I guess it means that we can get rid of all these fields as sequential. Which were a pain. Okay. We will check that in. We'll replace eliminate filtering and sequential. Okay. Well, what we need to do now is continue parsing our document, making sure that's done, and then we'd be ready to move on to evaluation. Okay. Go back to that document to make sure that that was finished. Oh. What's happening there? Oh, come on. Right, well that was a bit painful. All I had to do was remove the namespace, and def methods have a habit of sticking around and being quite sticky. Anyway, that's looking better now. So we've got a few things that are not handled in our schema document, like the top level document. Doing our document. A document is made up of definitions. So we can say document that with definitions. Okay. No, that's right. Oh, why is it not handled? Every time you change a def multi, you have to remove the namespace. Otherwise, it just doesn't come on. just one little underscore, and that's all we need to get it back and running. Now, schema definition needs to be handled. So we have a definition. One of them can be a schema definition, which we're not handling. Okay, let's handle that. That would be a schema definition, which would have some terms. We can process those terms. And that would give us, if we apply merge, we'd have a schema. We need to handle a root operation type, which is going to be, again, some terms. This would be operation type. Okay. Let's write it like this: operation type. Don't care. Named type. Case process operation type, if it, and that would be something we would just process here, and return query application. We've done that up there, haven't we? We'll merge these. See what we get. Yeah. The schema is just saying the query is root. Go look up root. So that's our document. Put that in a vector. Arguments, definition, that in a vector 2. So, I think the idea being, if our schema was to have, you'll have to do this mutation, root, you have to do that if you wanted, and then that would have, yeah, query and mutation, but you couldn't do that. Okay. Well, there's going to be a whole load of validation stuff coming soon, because in the table of contents you have a whole bunch of stuff you have to do to validate schemas and documents. Well, everything's a document. Okay, last bit. Let's try and start with a document. We've got a schema. We've got our document. Because that's kind of our query, and we need to evaluate our, so to say, schema, we'll call it document for now, but we really want to call it the query, is graph query language, after all. So really we want to say to a implementation, hey, that's the stuff. Okay, that's the that's the schema, that's the document, or the query, and say, you know, evaluate that. Now there is a down at execution, there is a section on executing requests. So what we'd like to be able to do is say execute this request, and then what that should do is call into the build resolver, which is also known as your runtime, saying, hey, I've got this person, or can you find me person number 4? Anything would then return it a map. We should get some results. So let's leave that as a throw. So let's try and do that. We haven't got execute request here. But we have something called execution where we have execute request. Now I'm going to have a look at some of the tests I wrote before. Is what we want to see. Yeah, we're going to have at least a schema is going to give us types by name. But other than that, they're going to be pretty much the same. So that's what we're looking for. do a similar thing, process schema. So this is what we've got. This is what we want. In fact, for these results, I'm going to call my function so this is what we want. This is what we've got so far. Okay. So looking at this, let's try and identify the types, and we want to put them into a thing called types by name. Okay, and that's going to sort of be a map of the type. That's what we're aiming for. So let's first identify our type definitions, which are, so when we start executing, well, when we look at a document, we see a type system definition, and we get a type definition. That's the key one, type definition. And right now we're just processing. We kind of want to say, all right, this is a type. So one question I have is, if you're a type, do you always have a if your type definition, do you always have a kind? There's thing called type kind, which is, so I think the answer here is yes. You always have, well, no. Okay, let's find our type definition. As I said, into type definition. I suppose that's the definition type, and it would be a type definition. Okay, let's do that. At least then we can say that we have definition type. So we could have something to update so we want to search on something called types by name. That is going to be take the document, filter definition type is type definition. And now we have types by name, and we have, yeah, it looks like we've got, well, it's similar. If we look at the GraphQL test, actually we're not comparing like we like, so let's do that. Types by name, we'll write that to results, and what we're going to try and create is types by name. We've got root, field definitions, arguments definition, I think that's, yeah, it's pretty similar. Alright, now that's what schemas look like. They have a root, operation names as well. Okay. Root operation name. Okay. And then we have a root operation name. Come on. Okay. Root operation type names is the same. So now yeah, that's kind of going to be our new schema. Okay. Do some stuff on the document as well. What does that look like? Okay, we'll go with that one. operations by name. Okay. We don't have fragments, looks like that's all we need. So let's work on Yeah. Okay, this is the, I wasn't sure I would get this far, but yeah, that took about an hour and a half. But we have got a result here of Isaac Newton. So what's going on here is that we're getting a callback to a callback function called field resolver. Now, I have glossed over this, but execute request, these algorithms here are all defined in the specification, so under the evaluation section, section 6. So if you go to evaluate requests, you get a kind of pseudocode, which is what I've implemented here. So there's nothing too much to think about or too controversial there. So execute query will cause this. Just for documentation reasons, I've kind of passed everything as a map. I'm not sure if that's the most performant, but anyway, we can optimize later on. But yeah, this algorithm just goes through. I mean, there's a few missing bits and pieces, but it's more or less complete, apart from stuff like coercions. But anyway, there's not much to think about, so we can carry on implementing that another time. But if we give, so if we now, one of the things I'd forgotten to add into the types by name is this set of built-in types that GraphQL has. So I need to put those in, and then it was happy working. So what we can do here is, let's say that we did have profile pic, and profile. So if we were able to resolve a thing called profile pic, let's just check the schema. Is that what we had? Yeah, profile pic with some arguments. So let's just chuck in the argument there. Get in args. That would be let's see what it's going to be. It will be provided to us. Let's just throw the exception. So the point here is if we change the query to say, give me the profile pic, and profile pic takes some arguments. So if we gave profile pic an argument there, so if we say size, and we have to give it an integer, so it's size 100, and then we go back to here, then did we save it? We did save it. Argument values isn't being passed in. Never mind. But we can say if the type is person, there we go. Isaac Newton profile pic. If we change the query to not have that, we get that. And in fact, we can put in things that aren't in the schema, I believe, and it won't have any effect. Not sure if that's an error or not. So there is perhaps a bit of incompatibility with the arguments coming in. quick look at the query 3. So what does that make of query 3? Turn it into a document. What does it look like? Arguments ID. And the operations, so that's the elements. Let's use the ID. No. Put the profile pic. We should see it change to, we should get GraphQL arguments, so let's just pop that out. And let's compare that with our own attempt. How do these compare? As argument, the list of arguments definitely required. No. No. We're going to close certain arguments. We know the arguments is going to so we know an argument is going to be a name, and a an underscore, colon, and a value. Yeah. Almost there in the process. Arguments, it's like it's the same now. And there we have profile, picture, arcs, I think called a arguments in there. Argument values. That's called argument values. Come on. Argument values. Arguments. I don't even know what I'm doing here. I just want the arguments. something like this. Some number .png like that. Size. There we are. 100. There we are. So we can go to query, change it to 200, and back, and we get. So the arguments are working out. Okay. That's now working. That is now a test. Well, ready to be a test. I think we're going to leave it until tomorrow, and we will do a little bit of discarding some of the damage. 100. And simple execution. Example using ANTLR. Okay, pushing that to a branch, and we're done. So yeah, that was much slower than I had hoped, and quite painful. And I think I'm too tired to code, but anyway, there's quite a lot of cleaning up to do tomorrow. That's but anyway, it is the beginnings of a GraphQL implementation, which works against with ANTLR, works with June 2018 spec of GraphQL, and is fairly small enough to be self-contained. I mean, the only dependencies it has, it doesn't need this dependency on reap anymore, that can be taken out, and does need, we could maybe take these out tomorrow. Does need these two. So yeah, not a lot of dependencies, so pretty self-contained, but the point being that this is the main API in the interface, and the only thing that you would have to do as a service provider would provide that, and that's something that we can provide inside of site that would call out to Crocs, and it would get its clues from the directives. We got to design that as well. But yeah, it's looking okay. We could get our card implementation working locally and get some cards in the system, and then we can start using GraphQL to query them out. So yeah, a few more weeks, although I'm likely to go on a bit of a break until the end of August at least, so don't know how much progress I'll make on this, but I probably will continue doing a little bits and pieces on the GraphQL implementation, but not a great deal. So yeah, I hope you got something out of that session and learned a bit. There's quite a lot of closure code flying around. I mean, this is really was an exercise in me putting an existing code base or a bit of a prototype that I've been playing around with and kind of zipping it together with ANTLR, and there was a little bit of pain. We could have used closure spec in some of those places, but that would have taken a bit more time, and the specs would be changing quite a lot. So we're still very much experimenting and prototyping, but we're beginning to get something working, which is quite exciting. Always good to have GraphQL, and this would be very easy to pick up and make work, not just in site, but anything using Crux. We could even release this as a separate Crux library to make GraphQL work. So yeah, quite a lot of debugging and extra work to do. It's probably a few weeks away from an interim release, but anyway, hope you enjoyed the session and see you next time. Alright, bye bye.